Hello and welcome back to Unit 1. This is the fifth and final part of Unit 1, and in it we're going to look at vector addition and vector subtraction. We're going to look at each of these in two ways, both graphical and by components. So we're going to begin with graphical vector addition. Now I have a website here. We will go look at it for a moment because it's going to be able to do things a lot more easily than I can do. It can draw things better, if you will. But it's a good place to start by just drawing. If I have two vectors, let's say I have a vector A that goes up like this and a vector B that goes down. Okay. Then to add them together, what I do is I take vector A and at its tip I place vector B to within my ability to draw the same vectors twice. And then the sum of them, A plus B, goes from the tail of A to the tip of B. So A plus B would look like this. If I wanted to do B plus A, I would do the exact same thing, but in the opposite of order. So I would draw B first, and then at the tip of B, I would draw A. And then B plus A would go from the tail of B to the tip of A. And you can see that B plus A and A plus B are actually the same. And that is because addition, I believe that's the commutative property, that 2 plus 3 equals 3 plus 2. So you get the same value, the same both ways. Let's take a moment now and jump over to the simulation. Here is the simulation. Let's start with one-dimensional. So if I take and put down vector A, and I want to add vector B to it, so I'm just going to put it there. You can see the sum goes from the tail of A to the tip of B. And if I take B and make it smaller, becomes smaller. Now I'm trying, oh, that's not what I wanted to do. Trying to make B negative and point it the other direction, but I wonder if I drag it through. Aha, if I drag it through. So if I take A and B and add them together this way, you can see I get smaller, something smaller than both of them. Now in this case, I am not adding components together. I am adding two separate vectors together. Right? So A has its x component and B has its x component. And that leaves me with the sum of A plus B. Let's move out of a one-dimensional world and go to a two-dimensional world. So I'm going to define my vector A. And notice it gives me information up here. It tells me the magnitude of A is currently 10. The angle it makes with respect to the x-axis is 53.1. The x component is 6 and the y component is 8. So if I take and define a vector B, now notice I've made vector B have a x component of 6 and no y component. And now I'm going to make C, we got to flip C around. Bring it down. You can see the nature of vectors here. Here I've defined B and C to be exactly equal to the x and y components of A. And you can see that A equals B plus C. Oh, this, however, does not work to be that because this is doing A plus B plus C, not just B plus C equals A. It's twice as long as A, if you will. So let's get rid of that. Right. If I make A longer or change it, let's get rid of C for the moment. Bye-bye C. And now I can do sum. So A plus B equals the sum, which is S. If I make B longer, if I change its direction, ta-da, Okay, so that is graphical vector addition. I now have a couple of questions for you based on what you've seen. If I have a vector v, which equals the sum of two other vectors, v1 and v2, does the magnitude of v have to be greater than either v1 or v2? And hopefully you're thinking no, and you're remembering the example we just did where we had A going this way and B going that way, and the sum was this little itty bitty thing. In fact, if I made A and B equal in length but opposite in direction, my sum would be 0. So the magnitude of V does not have to be greater than the length, the magnitude of either V1 or V2. So the next question, can two vectors of unequal magnitude, unequal length, ever add up to give a vector with a length of 0? And hopefully, again, you're remembering the example we just did. If I want to add up to 0, I have to have equal length. If my two vectors are not equal length, I can't get them to add to 0. What if I have three vectors of unequal length? Well, here I can. I just have to do it carefully. If I'm working in 2 dimensions, I could do this one and that one and this one. I have to have the length set up so that it works. If I'm working in 3 dimensions, I could do something like this, where I'm going around in a circle and none of them are the same length, and therefore it meets the criteria. So the answer to the first one is no. The answer to the second is yes. Okay. Next, we're going to do an example of vector addition using components. So let's say what did I just do? I have no idea. Let me see if I can fix it. Oh, good. Let's say I have 2 vectors. So my vector v is going to be 3, not x hat. I told you I'd try to use ijk, and here I am goofing it up already. 3i hat minus 4j hat. And I have a vector, let's go with w, equaling negative 2i hat plus 6j hat. Okay? And I want to find v plus w. When I do this addition, I add x components to x components and y components to y components. So this would equal 3 minus 2i hat, 3i hat minus 2i hat, plus negative 4 plus 6, all in the j hat. So that's 1i hat plus 2j hat. Let's take a moment and go back to our simulation and see if that's what we get. Okay, so our first vector was, I'm going to get rid of that sum for a minute, had a length of 3i hat, and forgive, I don't remember what it was, 3 and negative 4. Okay, so I've got the 3, I need to go to negative 4. Okay, so the x component is 3, the y component is negative 4. The other vector we had was negative 2 and 6. So negative 2x and 6 in, 6 in y. And I want to find the sum of these. Here it is. And if I look, it's got an x component of 1 and a y component of 2, which is completely consistent with what we found here. Okay, so that is vector addition. Vector subtraction is done very similar to vector addition with a small change in sign. Okay. So if I have a vector A and a vector B, and I want to find A minus B, and I want to do it graphically, I start the same way I did before and draw my vector A. And now I'm going to rephrase this. Instead of being A minus B, as A plus negative B. Now why do this? Because I know how to add. And I know what putting a negative in front does. It just changes the sign of everything. So anything that was positive is now negative and vice versa. So negative B will point upward and be the same length as B. Okay, the negative flips the direction on it. So my vector A minus B points from the tail of A to the tip of negative B. Okay. Now by components, it's very similar. So I'm going to define two new vectors. And I'm doing these examples in 2 dimensions. The same would hold for 3, I should say. So A is going to be, say, 3 I hat minus 4 j hat, and let's let B be negative 2 I hat minus 3 j hat. So now if I want to take A minus B, I'm going to take my I component of A, or my X component of A, 3 I hat, and subtract off the X component of my vector B. And that's my I hat direction. And then add to it the Y component. So that would be minus 4 minus 3 j hat. Okay, so 3 minus 2 is 5. And negative 4 plus 3 is negative 1 j hat. Okay, now we did this graphically and showed that A plus B equaled B plus A. The same does not hold for A minus B and B minus A. So let's take a moment and do B minus A. So B minus A will be negative 2 minus 3 I hat plus negative 4 minus negative 3 j hat, which works out to be negative 5 I hat minus I have a sign error on the top one. No, I do not. Hold on. Oh, I wrote them in the backwards order. Let's fix this. This is the problem. It wasn't working out. I have solved it. Let's rewrite. I'm doing B minus A, so I need the negative 3 first minus negative 4. And that works out to be positive 1 j hat. So you can see A minus B and B minus A have the same components with all of the signs flipped, which is true for subtraction in general. If I take 2 minus 3, I get negative 1. If I take 3 minus 2, I get positive 1. So the answer is the same to within a minus sign. Later in the semester, or later in the course, we will also be working with vector multiplication, but I would rather cover that when we get closer to needing that material, so you have something to look forward to. This is the end of this part of Unit 1. It's also the last part of Unit 1. I will see you for Unit 2.